For any exam-related queries, call us at +1 678 648 4277. You can mail us at support@statisticsexamhelp.com or reach us at https://www.statisticsexamhelp.com. 1. Probability plots. Random samples of size n equals 100 were simulated from 4 distributions: uniform 0, 1, exponential 1, normal 50, 10, students t, for degrees of freedom. The quantile plots are plotted for each of these 4 samples: uniform QQ plot, normal QQ plot. statisticsexamhelp.com. Exponential QQ plot, TDIST QQ plot. For each sample, the values were rescaled to have sample mean 0 and sample standard deviation 1. The normal QQ plot for each set of standardized sample values is given in the next display, but they are in a random order. For each distribution, identify the corresponding normal QQ plot and explain your reasoning. Uniform 0, 1 equals plot, exponential 1 equals plot, statisticsexamhelp.com. Normal 50, 10 equals plot. Students t, for degrees of freedom, equals plot. statisticsexamhelp.com. Solution. The student's t sample has 2 extreme high values and 1 extreme low value, which are evident in plot A. So plot A equals t distribution. Plot B is the only plot that has a bow shape, which indicates larger observations are higher than would be expected for a normal sample and smaller observations are less small than would be expected for a normal sample. This is true for the exponential distribution, which is asymmetric with a right tail that is heavier than a normal distribution. Plot B equals exponential. The uniform 0, 1 sample has true mean 0.5 and true variance equal to e x2 minus e x2 equals 1/3 minus 1/2, 2 equals 1/12. For a typical sample, the standardized sample values will be bounded, using the true mean and standard RD deviation to standardize. The values would no larger than +1 minus 0.5/1 divided by 12 is equal to 1.73. For plot C, the range of the standardized values is smallest, consistent with what would be expected for a sample from a uniform distribution. Plot C equals uniform distribution. statisticsexamhelp.com. The QQ plot for the normal distribution is unchanged and follows a straight-line pattern indicating consistency of the ordered observations with the theoretical quantiles distribution. Plot D equals normal. 2. Betas for stocks. In S&P 500 index. In financial modeling of stock returns, the capital asset pricing model associates a beta for any stock, which measures how risky that stock is compared to the market portfolio. Note, this name has nothing to do with the beta A/B distribution. Using monthly data, the beta for each stock in the S&P 500 index was computed. The following display gives an index plot, histogram, normal QQ plot for these beta values. Index plot of 500 stock betas, X. statisticsexamhelp.com. Histogram. Normal Q minus Q plot. For the sample of 500 beta values, X equals 1.0902 and SX equals 0.5053. A. On the basis of the histogram and the normal QQ plot, are the values consistent with being a random sample from a normal distribution? statisticsexamhelp.com. Solution. Yes, the values are consistent with being a random sample from a normal distribution. The normal QQ plot is quite straight. B. Refine your answer to A. Focusing separately on the extreme low values, smallest quantiles, and on the extreme large values, highest quantiles. Solution. Consider the extremes of the distribution. The high positive points appear a bit higher than would be expected for a normal sample, suggesting there are some outlier stocks with higher betas than would be expected under a normal model. The lowest values near zero appear a bit above the straight line through most of the ordered points, suggesting that the stocks with lowest beta values aren't as low as might be expected under a normal model. Bayesian analysis of a normal distribution. For a stock that is similar to those that are constituents of the S&P 500 index above, let x equals 1.6 be an estimate of the beta coefficient theta. Suppose that the following assumptions are reasonable. Statisticsexamhelp.com. The conditional distribution x given theta is normal with known variance. As a prior for theta, assume that theta is normal with mean and variance equal to those in the sample. C. Determine the posterior distribution of theta given x equals 1.6. Solution. This is the case of a normal conjugate prior distribution for the normal sample observation. The posterior distribution of theta is given by where and statisticsexamhelp.com. Plugging in values, we get D. Is the posterior mean between x and prior? Would this always be the case if a different value of x had been observed? E. Is the variance of the posterior distribution for theta given x greater or less than the variance of the prior distribution for theta? Does your answer depend on the value of x? Solution. D. Yes, the posterior mean is a weighted average of x and prior, which will always be between the two values. E. The variance of the posterior distribution tau2 equals 0.186, 2 is less than 0.5053, 2 equals sigma 2 prior. From part C, the posterior variance does not vary with the outcome x equals x. Statisticsexamhelp.com.